moon, different sides of the moon, and you can see this is the albedo of the moon at different location of the moon, and this is the Pmax also calculated from the Earth, and you can see there is a clear correlation between polarization maximum and albedo. So experimentally it is true, and it was done by one of the pioneer in this field, Sturatov from Russia. In 1993 he published this work, and you can see in both the wavelengths it is showing a very nice correlation. So in case of comet, the albedo is close to 2 to 10%. So you may expect that comet contains the absorbing particles, means the carbonaceous particle, without going to detailed study. Because as I told you, if albedo is minimum, it means that the absorbing particle should be there in that. So just looking at this albedo value, you can have idea whether the carbonaceous particles are there or not in a particular object. So these are the recent works on UMO effect, particularly Zhukko from Ukraine. You know, now Ukraine is having all this war, and I don't know about Zhukko. Zhukko was actually presenting one paper in our university through online mode. But recently I contacted the Zhukko and others, but they told me that their research is stopped in Ukraine. They could not go, but after 2020 they don't have any papers on this particular, because Zhukko is actively working in that field. But unfortunately, because of the war between Ukraine and Russia, they could not work. Anyway, so Zhukko had done a very nice work in this field, and that's why I have referred. So in my work particularly, these are the models. Probably in the beginning of my talk I showed you that how cosmic dust looks. So particularly in modeling, we are creating this particle using Monte Carlo simulations, and this is the particle how it looks. And you can see these are three types of particles: BA, BM1 and BM2. BA porosity is 0.87, porosity 0.74, 0.64. Porosity will tell you about the fluffiness of the particles. More the porosity, higher is the fluffiness, and you can see particles are more compact in case of BM2. Okay, BM2 is name is ballistic agglomeration with one migration, like that. Okay, so BM2 particle is more compact than BA particles, and our study is based on how porosity is affecting the Pmax and albedo. That is our objective of our study. So this is how porosity is defined, and we have taken three types of particles with different type of structure. These are random structure, so we consider three random structure, and the porosity is 0.87, 0.74 and 0.64. And you use T-matrix code. This is the light scattering code. I am not going to detailed part because this is too much technical. So using T-matrix scattering code, we actually executed our code, and the result which you are getting from the study I am showing you. And this is actually albedo along this direction. Log A means we have drawn this curve in logarithmic scale. So this is logarithmic of albedo, and this is Pmax, and you can see that there is a strong correlation between the structure of the particles. Means porosity is a very important factor here. So BA has the highest porosity and BM2 is the lowest porosity. So if porosity is increasing, means porosity is decreasing, polarization is also decreasing, and albedo is increasing. Okay, similarly if you go to other wavelength, the similar nature is observed. So this is the effect of porosity, how porosity is affecting the polarization maxima in this study. So these are the things. So if you take the aggregate size parameter, means if you consider the bigger size, that also affects the polarization curve, polarization albedo curve. So this is the effect of composition, means if you change the composition of the particle, that also affects the this polarization and albedo curve. Okay. So from our study, we found that the effect of porosity is very, very important in UMO effect, which was studied in 1905, and a strong dependence on porosity is observed for the first time by our group. And as I told you, this paper, the plot which I have shown here, it has been recently published in MNRS. And from that paper, you can see that porosity has a strong effect on this pollution and albedo. And another important parameter is the size parameter. Size parameter means if the size of the particle increases, it has also effect on the pollution curve. So individually we have also studied that one. And strong dependence of refractive indices. Refractive indices is very, very important, as I told you, because you know that whenever you are going to study a particular object, you have to idea about what type of objects you are considering, whether it is a metallic or carbonaceous. That will be decided by refractive index. And as I told you that if you are considering gold particles, then their refractive index will be totally different as compared to the carbonaceous particles. So here refractive index is very, very important, and we have shown that the refractive index of the particle is very, very important in this type of study. So particularly in this work we have shown how the refractive index as well as the porosity is affecting that pollution albedo relation, and in future also we are working on that, and we will have more information regarding the structure of these asteroids. And one more important point I would like to share with you is that since it is not possible to observe asteroid from Earth because of its small size, even probably last year also we are trying to observe asteroids from Aries Observatory, but Gulabsha was also there, I think. Gulabsha and Bhaskar, they went to that place, and observing an asteroid is a very difficult task because of its magnitude is around 90 to 20. Size is very small, so very difficult to observe, and we don't have much information from the observation, because satellite is particularly dedicated to these big objects like star, then galaxies, and black holes. But these small objects are always ignored by the people. But you know that small objects can bring disaster sometimes. So now NASA is coming with some new missions, and their primary objective is to study all those asteroids. And we have very limited experimental result. But anyway, whenever experimental result will come, it is fine. But we can develop the simulated results so that in future, even if we are not there, they can actually compare our results. So that's why we are doing this type of simulation, because after doing all this simulation, referee asks us, what is your experimental evidence? So we are very sorry, we don't have too many experimental evidences. But we can also produce this type of environment in the laboratory also. So laboratory experiment is also going on. In our department also, Professor Ashok Shen had set up a light scattering experiment in the laboratory, and they have published a couple of papers related to that. So we can also create the laboratory, the asteroid-like environment in the laboratory also, and we can study all those effects in the laboratory itself, and we can generate the data and can compare our result with the this experimental data. But as you know, it takes time. We have started our work, and I believe very soon we have some more interesting results. Maybe in next NEMA we will come up with some new results. So thank you very much for giving me time. I think I have completed before.
Yeah. Thank you for being timely. Okay. So let us thank Professor Das for his exhaustive and interesting talk. Now the talk is for discussion. So is there any question? It is open for discussion.
Just try to see the slide just before the conclusion slide. Yeah. You said about effect of the composition. Just I was trying to figure out how the K parameter or.
Okay, I am showing you. Here, actually composition of the particle was described by two parameters. One is real part of refractive index, normally we use it, and another is absorptive index, is K. So here you can see N is equal to 1.6. Normally for silicate particle the composition is 1.65, 1.7 like that. And for carbonaceous particle, it is around 1.9, 2.0. Like that. So we have taken two different refractive indices, and we are changing K. K means absorptive indices. Okay, so you can see there is a clear correlation if we change K. Okay, here also, and you can see the slope of the curve is different in these two graphs. And also the Pmax and albedo values are also different. Okay, so it is clear from these two plots that if you consider silicate type of particles, it will show you the more Pmax as compared to the carbonaceous particle. So more absorbing particle will show you less, means the Pmax will be less in case of this highly absorbing particles. So these are the two cases we consider. Now we are actually particularly concentrating carbonaceous particles, because as I told you, 67% of the particles are carbonaceous in asteroids. So now we are particularly concentrated on carbonaceous type particles, and we have got some interesting results. So probably I'll show you in next NEMA. Yes,
So
madam.
there is no archive data regarding asteroid observations and all.
Archive data is there. Yesterday, Vicky had shown you that asteroid polarimetric data and albedo data is there.
Regarding this compositions and all which you are talking about.
The composition is not there because they have only detected the polarization value and this albedo. And regarding the composition, as you are talking about, very few asteroids have been studied in spectral region.
So what about the percentage you have given in the beginning of the presentation?
Percentage of carbonaceous percentage was basically, it is coming from the albedo.
Okay, so you
Mainly from the albedo, and some of them have seen that they may have this carbonaceous composition because of its location in that region, and mainly from the albedo.
okay, so from
Yeah.
the video when only you are relating and you are saying that it's
You know, I am not relating, but if you go to the asteroids classification, so they have classification like that, carbonaceous as well as silicon, and mainly these are coming from this albedo. Otherwise, you cannot actually predict about the composition of the particle until and unless you have the data for spectra. If the spectral data is not available with you, you cannot actually predict. And another problem with the asteroid observation is that whenever you will take an observation from Earth, all those asteroids, you cannot go beyond 30 degree phase angle because of its location. Okay, so we don't have any data beyond 30 degree. And we can also actually also expect the composition from polarization study. Okay, so that we are trying, because if we can make a model of simulation and using all those parameters as you have seen, the refractive indices of those particles, then we can expect, we can do it. And in laboratory it was possible for us to test the scattering theory, but as I told you, we don't have data beyond 30 degree. So in that case, we need spacecraft observation of the asteroid, and very few spacecraft have polarimeter. So photometer is there, but polarimeter is not there. So until unless you have polarimeter, you cannot go for polarimetric observation from space. So this is the main issue with the observations.
And I remember like one student of Professor Sekhar, so once he was claiming that he found some small piece of meteors or something like that. How much sure is that? Pieces of meteors like that?
Yeah, that student is not there, but normally what happens, until and unless you actually go to laboratory, you cannot say that this is a meteor. Meteor has a special type of composition. Carbon dating is also required for those piece of materials. So until and unless you send to physical research laboratory or those laboratory, you cannot actually tell whether, and from the impact also you can say, if there is an impact in the site, then if you get a stone-like things, then you can, preliminary you can say that this is a meteor. But until and unless you go for laboratory studies,
But now there is no such study.
No such studies there. He had not continued as student. And I don't know, it was fallen in Dibrugarh, near Dibrugarh area. That asteroid was fallen, meteorites. And he was actually trying to collect that materials. I don't know whether he had collected or not. But he had tried. He has shown it. But I missed it.
But we cannot be very much sure whether it's the real thing or not.
He collected one asteroid, meteorite sample, one of our scholars. But later he left the institution. But our plan was to send the sample to physical research laboratory to check whether it is. And if you are getting direct samples, so it is easier for you to study in the laboratory also. Yes, you can have direct information regarding the composition of the particles.
Is there any more question? If there is no more questions, so let us thank the speaker once more for exciting talk.
Thank you very much.
Okay, thank you so much.